Okay, let's discuss the next concept. When an experiment is performed, a particular event A is said to occur if the resulting experimental outcome is contained in A. For example, let's look at random experiment 1. Flip a failed coin twice, and we observe what? We observe head-tail. Question 1. Does E1 occur? Answer is what? No. Why we say no? Let's take a close look. What's E1? Well, recall. E1 is we see what? 2 heads in a row. Okay? So of course, head tail is not in what? E1. So we say E1 doesn't occur. Now how about E2 occur? Does E2 occur? Now look at here. What's E2? E2 is we see exactly 1 head. So it's head tail or what? Or tail head. And head tail is 1 element in what? E2. So does E2 occur? Yes. How about E3? E3 is an event that we see exactly what? 2 tails. Tail, tail. So does E3 occur? Well, head tail is not an element in what? In E3. So we say no. Similarly, let's look at E4 and E5. Okay, what's in E4? E4 is that we see what? A head on the first flip. A second flip can be head or what? Or tail. So let's see. Is head tail is an element in E4? The answer is what? Yes, it's in here. So does E4 occur? Well, we say what? Yes. Similarly, does E5 occur? What's in E5? E5 is we see what? We see a tail on the second flip. As for first one, it can be head or what? Or tail. So head tail is what? In E5. So again, we say this is what? We say this is yes. Okay? So let's review the concept very quickly. When an experiment is performed, we say a particular event A occurs. Okay? We say a particular event occurs if the resulting experimental outcome is what? Is in the set A. In the set A. Okay? Now, next one. We're going to introduce you an equiprobable sample space. What is an equiprobable sample space? Definition. All possible outcomes in the sample space are equally likely what? To occur. For example, sample space 1 is an equiprobable sample space. Okay? And sample space 1, let me write it here. S1 is what? Head head, head tail, tail head, and what? And tail tail. This is equiprobable. Okay? This is equiprobable. Now, next I'm going to give you a sample space that is not equiprobable. Okay? So let's look at random experiment 4. Suppose I flip a biased coin twice. And how biased is a coin? The chance of getting heads is not 50%. The chance of getting heads is only 1 over 3, 1/3. Okay? This is a chance of what? Of getting heads. Okay? Is 1/3. So what is sample space 4? Sample space 4, head head, head tail. Tail head, telltale. Now, if you look at S4 and S1, if you look at what? S4 and S1 closely, you find they looks what? Exactly the same. But can I say S4 equal to what? Can I say S1 equal to S4? Okay? The answer is what? The answer is no. Okay? S1 is not equal to what? S4. Why S1 is not equal to S4? Okay? Here's a reason. Here's a reason. Okay? S4 is not an equiprobable sample space, but S1 is. What does that mean? Now, look at the probability. How likely you see two heads in a row in random experiment 1? Okay, or you say this produce what? Sample space 1. Well, the chance is you see the first head is a fail coin, so 50% chance. Second time, how likely you see a head again? Well, the same coin, right? Still a fail coin, so it's 50%. 50% times 50%. So the chance is what? A quarter. Okay? Same thing for the rest. How likely you see head, tail in random experiment 1? That probability is still what? 1/4. And this is same as what? Well, tail head. In what? Random experiment 1. Okay? And this is also equal to what? Tail in random experiment 1. Their chances are all what? Equally likely, which is 25% chance. Okay? However, let's look at probability of seeing what? Head in random experiment 4. Now, remember, the coin is not a fail coin. To get a head, the chance is only 1/3. To get a second head, since we flipped the same coin, still what? 1/3. And that probability is 1/9. Which is not equal to probability what? Of getting two tails in a row in random experiment 4. Okay? Now, to get a head, the chance is 1/3. That means to get a tail, the chance is 2/3. How about second tail? Still what? 2/3. So 2/3 times 2/3. 2/3 to the power of 2, which is what? 4/9. So, in sample space 4, or in random experiment 4, we are more likely to see two tails in a row than what? Two heads in a row. Okay? They don't have the same probability. So, S1 and S4, they just look alike, but they are not the same. Okay? S1 is an equiprobable sample space, but S4 is not an equiprobable sample space. Now, what is the reason we talk about equiprobable sample space? What is the reason we talk about equiprobable sample space? What is the reason we talk about equiprobable sample space? Here is the reason. Given an event A, okay, given an event A in the sample space, in the equiprobable sample space, given that an event A in an equiprobable sample space, okay, we have a very nice formula. Now, probability of that event is a number outcome in that event divided by what? Number outcome in the corresponding sample space. For example, sample space 1 is equiprobable. and a subset in the sample space 1, say E4 or E5, okay? How many outcomes are there in E4 and E5? Let's see. E4 or E5 has what? Head tail and head and what? Tail tail in it. Okay? So how many possible outcomes are there in E4 or E5? The number is what? The number is 3. And how many outcomes are there in sample space 1? 4. So how many outcomes are there in what? What is the probability of what? E4 or E5 occurs? Well, that probability is what? Number outcome in E4, E5, which is 3, divided by number outcome in S1, which is 4. So the chance is 75%. Okay? Next one. Let's talk about intuitive probabilities. Intuitive probability is a long-run proportion of repetition on which an event what occurs. Next one, I'll introduce you basic probability rules. To understand the following property rules, okay? To understand the following probability rules in a more intuitive way, you can assume what? Sample space is equiprobable. Although this is not necessary, but if you assume the sample space is equiprobable, you can understand those rules in a very intuitive way. Okay? You can understand it in a very intuitive way. Basic probability rules. Okay? Now, rule number one. Probability A is between 0 and 1. How can we see this probability rule in an intuitive way? Well, let me draw you a Venn diagram. Okay? This is S. And A is an event in S. If sample space is equiprobable, if this is equiprobable, then probability A is a number outcome in A divided by number outcome in the sample space. Okay? Now, how likely A will happen depends on the ratio. Say if I keep tossing what? Outcome one by one into A. And make A become what? Bigger and bigger and bigger. Okay? How big can A be? Well, the biggest one is what? When A become what? Become the whole sample space. When A become the whole sample space, what is the probability of A? It's number of outcome in S divided by number of outcome in S. And that is 1. So probability is at most what? 1. On the other hand, if I take outcome one by one from A, and make A what? Shrinking. How small can A be? If I take out everything in A, what number outcome in A? Well, 0. So 0 divided by number outcome in S is what? Is 0. So probability is what? At least what? At least 0. Okay? This is rule number 1. Rule number 2 follow the same argument. You can see probability of sample space is what? Is 1. That is to say, sample space, okay, will happen for sure.